Hello and welcome to Getting Started with Xamarin and Azure. My name is Mike James and I'm a program manager at Microsoft. I've written a couple of apps that are available on GitHub for you to download, which may be useful in the context of learning Azure. So we'll be looking at the first two here, which are beer drinking and bait news. Both are for iOS and both make use of services within Azure, but the way that these apps have been built are very, very different. And it's because they kind of fill two different niches. So the first one, this is my long running weekend project. It feels like I've been building this app for eternity. It's been about a year in development, but I iterate it an awful lot. And part of the reason that I iterate it an awful lot is because I chose the right architecture to be able to do that. So this is what I like to call the enterprise grade architecture. So if you look at the solution here, you'll see that we've got projects for days. There's an awful lot of projects within here. But we've got our core abstractions. So when we're dealing with things like beerdrinking.datastore.abstractions, which you'll see within the abstractions folder. Data stores, that's just our table storage. So that's going to be SQLite. And then we've got services. Well, that's just going to be our REST APIs. And then we've got implementations for that. And you can see I've got the folder Azure. And because I'm using Azure, but let's say I switched over to AWS, I could just as easily swap out to AWS. Especially with this architecture, my client app wouldn't need to change. So I could leave the beerdrinking.ios and I'd only need to work in the portable class libraries to make the huge architectural changes. So this is the correct approach if you're developing an application with other people. You have a reasonable sized team, you want to use that solid approach to developing your .NET applications, then this is the right architecture. And this isn't an architecture that I've come up with on my own. This is an architecture that has been developed and crafted over probably 6 months, if not more, probably more. It's got to be more actually. But it's an architecture that both myself, Piers Bogan, and James Montemagno have crafted in order to get the most amount of code reuse and flexibility. Now, we've used this architecture in My Driving, which is a sample app we built for Build 2016. We also use this same architecture, if not slightly modified, for the Xamarin Forms demo, which is the Xamarin Evolve application available in the App Store and on GitHub. So this is a pretty solid, proven and tested architecture to use to building Azure connected backend, client apps and backends. As I say, the backend on this is a full ASP.NET backend, so you're going to have to write some C#. The client portable class libraries, there's a lot of them, and it can be a little bit intimidating. And if you're just writing an app for yourself and it's kind of a weekend project or it's a proof of concept, then this architecture is going to be a bit heavy for you. So we have the opposite for that available to you. If you go onto my GitHub, mikecodes.net, you can search for bait news, you will find this sample. Now the idea of this app is to see, can you spot the difference between a real headline and a fake headline? So I pull in headlines from some of the best tabloids, and when I say best tabloids, I mean most humorous tabloids from Britain. Then I also pull in headlines from satirical websites like The Onion and the Daily Mash. And the idea is, can you spot the real headline versus the fake one? Now, I wanted the UI to be pretty, and I stole the Tinder style user interface, so it's that card swiping. I didn't use any components. This is built entirely with C#. But I wanted to focus on the UI and not on the back end or on how to connect to the data. Initially, I had thought about just saving the headlines as XML and parsing them on startup, but that means if I want to update the application and update the headlines, I've got to roll a fresh update, so a point release, which means going through the review process. It means telling Apple what I've updated, and it's just a nightmare. I'd rather just be able to give new headlines through the cloud. So I decided to go with easy tables on the back end. Now, easy tables allows you to upload an Excel spreadsheet to populate your database. Easy tables is built around Node.js, so it's not an ASP.NET backend, but it's still running in App Service, so it's just a tab within App Service. So we can still scale out and up and have all the luxury of a normal app service that might be running ASP.NET, but this time we're running Node.js and we have very easy access to CRUD operations. So I uploaded my spreadsheet with my headlines. And then in my mobile application, to connect to that, I could have gone ahead and created a similar architecture to beer drinking. But again, I wanted to minimize the amount of code I was writing. So I grabbed a library called App Service Helpers. And this is a great library, but I've got to admit I'm slightly biased in the fact that I co-created it with Piers Bogan, my podcast co-presenter. So App Service Helpers is a library that's kind of come from just a year's worth of hardcore Azure development. We're doing the same stuff over and over again, and Piers and I found ourselves asking, well, why is this stuff not included in the standard SDK? Now, we know the reason why a lot of this stuff isn't in the standard SDK, and that's because what App Service Helpers is an extraordinarily opinionated library about the technologies you'll be using to build your app. If you're using SQL Azure on the back end with entity framework or easy tables, then this library will work for you. If you kind of fall outside of that scope, then this library isn't going to be that useful to you. But for all of the apps that we're building, they all fit within that same box. So this library is perfect. And what it allows us to do is to connect to our Azure backend either with ASP.NET or easy tables. It doesn't matter on the backend what you're using. The standard Azure SDK will work perfectly, but also our App Service Helpers will work perfectly. So with App Service Helpers, we're able to connect and fetch that data in 5 lines of code, but it only takes 4 lines of code to get things initialized. So you can see to start with, we need to create an instance of Easy Mobile Service Client. We then pass in our Azure Service URL into the initialize method. Now it's worth noting that the Azure Service URL should be a domain name. It should not be an IP address. If you hard code your IP addresses into your app, you are asking for trouble. As soon as you go to the review process with Apple, they're going to test it on an IPv6 only network. It's going to fail because you're probably only giving it an IPv4 IP address, at which point your app will get rejected. So you want to be making sure that your app works on an IPv6 only network. So that's very, very important. Apple do have documentation on how to test that in case you're wondering. Do go and check that out. So once we've given the Azure Service URL, we need to register our tables. Registering tables, we're just going to provide objects that we want to store and we have in the backend as well. So in this case, headlines. And then we finalize the schema. Once we finalize the schema, we can create an observable collection, but with this extra little bit at the front, which is connected. So this is a connected observable collection, and it means that any CRUD operations that we do on this observable collection will be pushed back to Azure, and then we can also refresh it. So that's pretty neat. I really like this approach to building Azure apps because it's just so simple, 5 lines of code. And actually I put the 4 lines to get started, normally in the app delegate or the main activity. And then I just, within my view models or my view controllers or my activities, can create this connected observable collection of the objects I need, and boom, I'm good to go. It's very, very lightweight. So big fan of this approach for the kind of apps where it's just you and you want to get it out the door pretty quickly. So the shopping demo app that we're going to be talking about today kind of sits between these two approaches. So it's not quite as easy as App Service Helpers, but it's nowhere near as complex as beer drinking. So we've built this using the traditional Xamarin development style. So that means it's not using Xamarin Forms. So we've used storyboards for iOS, Android, XML for Android, and XAML for UWP, and then it just calls into some shared code. So we're looking at around 75% code reuse across all 3 platforms here, but it changes and varies depending on each platform, but as a minimum 75% is what we should be aiming to achieve. So in today's webinar, you will learn the following. You'll learn about backends and how to deploy them. There's a couple of different options. I'll look at the pros and cons for each approach. We'll look at some of the services that we can plug into our app service in order to get some awesome backend features for free. And then also we'll look at the architecture for the mobile app and how to build the UI, and then take a look at some resources for how you can learn more. Hopefully you'll leave this with a pretty good understanding of authentication. There are a couple of ways to authenticate your Azure apps, some of them right, some of them wrong. I tend to lean towards doing the wrong approach just because it's easy, and I'll talk about why you shouldn't use that approach. We'll look at offline sync, which is one of those just exceptionally important features. We'll look at push notification, and then lastly, cognitive services. So this is a project in two halves, or a solution in two halves, I should say. So you can see here we actually have two solutions. We have the backend solution, which contains our ASP.NET backend. It's our app service. So it's got some special app service NuGet packages that unlock some magic for creating mobile backends. And then we have our client apps, which is our traditional Xamarin solution. So this has got 4 projects within it. It's got our shared code, our iOS project, our Android project, and our standard UWP project. So I like to always start from the back end and work forward, just because it's always useful to get an understanding of how does the back end work, what are we going to be calling into. So why don't we take a look at backends? So mobile backends as a service with app service. Well, why would you want this? Well, one of the main reasons you're probably going to want this is the ease in which it allows you to build very, very complex functionality into your applications with minimal amounts of coding and minimal time. If we take sign-on as an example, you can see you can add corporate sign-on in seconds. It's just one line of code and boom. You can authenticate against Active Directory, or you could do social auth or custom auth. In fact, if you want to see custom auth, go and have a look at the Evolve app that we built, the Xamarin Forms demo app that I was mentioning earlier. We use custom sign-on for that. You can do offline data sync to build responsive apps. And often people think, well, why is offline data making my app more responsive? And the answer to that is that you don't just want your data offline, you also want to minimize how far away your data is. Because when you're doing CRUD operations, it's not that useful if the server is 2,000 miles away. What you want is the database that you're saving to be as close as possible. And with offline, your database is on the device. So all your CRUD operations can occur on the local SQLite database on device, and then at a suitable time that's convenient to everyone, you can then go ahead and sync those data changes or database changes back to Azure, and then sync those down to all the client apps that are subscribed. So what that means is that when you're trying to read some data from a table, you're actually going to read it from the SQLite database, so you're not going to have to do a round trip. So it means your app is going to be infinitely quicker and more responsive. You can also connect to on-site, on-premise data, I should say. So if you've got a SQL server already provisioned and set up in the office, and you don't want to move that data into Azure, or you can't move that data into Azure for security reasons, well, you can create a hybrid cloud. So you can connect into your on-premise data and still get all of the goodness of app service without compromising on perhaps your security or your work policies around your data protection. Should be noted that most countries now have some form of agreement with Microsoft in terms of Azure, in order to meet local regulations. So if you're building healthcare apps, there's a good chance that you can still store your data in Azure. They meet lots of regulations. I think the most in the world, more than competitors. Anyway, I digress. You're able to broadcast push notifications to millions of users in minutes. This scales to an obscene number of people, and it's very, very cheap. We pushed over 1 million notifications during the Evolve week in April, and it cost us less than $50. And that was running with a full back end as well, and storage and everything else. So it's very, very cheap for the amount of users that you can get using app service, but also with push notifications. It's very cheap, and you can push to lots of people, and that massively improves the number of people using your apps, because it kind of reminds them, hey, I've got this app installed. They may go uninstall it, but some of them will launch it. And you can scale to fit your business needs, and this is probably the most important one for why cloud is a good thing. So if you're not using cloud and you're trying to scale your backends in the office, what that's going to involve is going and buying more machines or more RAM and faster CPUs and upgrading the machine. That's going to get pretty expensive. I've not met anyone that's managed to provision a SQL server faster than I can with Azure. It takes me about 5 minutes. Most people take about a week to do it on premise. So that's a huge difference. With Azure, rather than having to go and buy new machines and wait a week or two to get them provisioned and set up, I can just go ahead and slide some sliders and it's going to do all of that for me. So I can say I want to scale up, which means I want more RAM, more CPU, more resources available to this one instance. So that's going to be able to deal with a flood of users fairly well, but there's going to become a point where that one machine is maxed out and you've still got lots of users that want to use your service. Well, you could either, slow right down, return some 404s, or you can scale out. And scaling out means that we're going to create another instance of our app service and start routing users to that instead of our slightly overrun instance. And we can set up rules around this. So we can say that when we're at 75% usage on one of our instances, we want you to start another instance and start routing users over to that. And then we can get an email to tell us that it's done it. So it's really nice that we can scale up and down automatically without actually having to do any work, which would normally be a huge problem for most businesses. It's a good problem to have if you need to scale up, but it can be an expensive and difficult problem to solve. And the guys at Microsoft have solved it for us and made it exceptionally easy. So we have some lovely .NET SDKs that are available to us as Xamarin developers, but there's also SDKs for iOS and Android, so Objective-C and Java, and then naturally the Windows SDKs. If you're a React Native developer, then there's SDKs available to you as well. Naturally, this is a Xamarin webinar, so I'm going to be talking mostly about Xamarin, but do keep in mind that it is all applicable to whatever technology you're using, certainly within the backend bit. So the SDK just wraps a REST API. So there's no magic. If you want to get rid of the SDK, you can do that. If you want to view the source code for the SDK, you can do that. It's all on GitHub. If you want to add new features, put in a pull request. I'm sure Adrian Hall and the team would love to see some community action on the SDKs. So it just wraps this REST API, and the REST API allows us to communicate with a multitude of different services. So you can see here we have data connections, we have Azure SQL, there's a MySQL preview going on at the moment, we can have table storage, so like blobs, we have Mongo, we have Office 365, we have API apps, and of course offline data sync is exceptionally important within this. In terms of user authentication, as I mentioned before, there are two approaches to doing this, the kind of right and wrong approach. I tend to use the wrong approach, and I apologize for that in advance. But let me explain what the problem is. So let's say we're using the simple approach, which is just one line of code to authenticate our mobile app. It's just a line of code within the Azure SDK, which will call up to the back end. And we're using social auth, so we're using Facebook. So in order to get that configured, I would have had to go into the Azure portal and I would have added my secret app ID, and some other secrets that Facebook gives you. In order to get those secrets, you have to register your app with Facebook. When you register your app with Facebook, they ask for a redirect URL, so that when the authentication is successful, they know where to redirect back to. So they want to know where your backend is living. Now, the redirect URL, you can only have one of them per app within Facebook. And this is where the problem comes, because if we're doing backend development properly, we don't just want to be deploying straight to production. Now, production, we're definitely going to want to authenticate with, so we're going to have that redirect URL set up for production. But we may have another slot available to us to deploy to called staging, which is where we do all our testing. So our URL for staging is going to be very different to our URL for production. So at which point our redirect URL from Facebook is invalid. So when we try and authenticate with staging or in staging, it's not going to work. So it means that you can't authenticate when you're testing with staging if you use this one line approach. And this is the approach that we use within this application today. it's the wrong approach to use for production software. Now, the correct approach to use is to grab the official SDK from the provider that you're authenticating with. So in this case, Facebook. So we go ahead and we'd grab the Facebook component from the Xamarin Store, and we would authenticate using that. And effectively, the flow for the user would happen like this. They click the sign in button just like previously, but rather than launching a web view, what would happen is we get launched into the proper Facebook app. And the app says, hey, do you want to allow access for beer drinking or bait news or my shopping sample app? And you say, yeah, I want access to that. And then it's going to hand you back into your application, but it's going to pass back a token. You can take that token, you can then pass it up to Azure, and boom, you're authenticated. And that is going to work no matter how many slots you've got, and it works really well. And it's also the best flow for the user because they don't have to type in their username and password like an animal for every separate app. It's just going to take them into their existing signed in official app by the social provider. So we can authenticate with Facebook, as I mentioned, Twitter, we can authenticate with Microsoft, Google, and Active Directory. We support push notifications with Notification Hub. We can do iOS or Mac OS, Android, Chrome, Windows, Kindle, and in-app. In terms of backend code, there's a variety of different products available to us and how we can get code up into Azure. If we look at deployments in a minute, but let's just briefly talk about CI. If you're using VSTS, Bitbucket, or GitHub, you can set up some webhooks to deploy your backend. And this is the easiest way to deploy a backend because what happens is you commit to GitHub, you push that commit, or you sync it, and GitHub will notify Azure Mobile app that this has happened. Your Azure Mobile instance will then go ahead and build the new version of the backend. You can run some tests if you really want to, but in most cases it's just going to build it and it's going to deploy it to a slot that you select. So let's say we deploy straight to production because we're animals. All we have to do to get that deployment to happen is just to hit commit and boom, we're done. Now that is a good approach to deploying, assuming that you don't deploy straight into production, but instead you go into staging. For this example, you probably don't want to use that approach simply because this is a sample app. So with this approach, there's an easy way to deploy the backend, and that's using the Azure Resource Manager template, or the ARM template. Now, you're going to see ARM in the context of Azure quite a lot the more you get into Azure, and it's always within the Azure context talking about Azure Resource Manager templates rather than the chipset. So that's worth keeping in mind. So we grab our ARM template, and our ARM template allows us to deploy a backend to Azure which has already been configured for us without actually having to do any of the work ourselves. So we get a button within the README of this project, and it says deploy to Azure, and you click that, and assuming you're signed in, which I was in this case, you'll be greeted with this screen. We can provide some information about what we're deploying, so we give it a resource group name and some information such as database name and login details. We're creating this, just to be clear, we're not having to, this isn't pre-existing information that I'm entering, we're creating this. We hit next and it's going to give us a list of all of the items that it's going to actually deploy. So in this case we get cognitive services, we get Azure SQL, we get an ASP.NET website, which is app service. We have Notification Hub, and then we have storage as well. And when we hit deploy, boom, it goes off and it deploys all of that to Azure. When it's deployed, we can hit manage your resources and we end up in the portal, and you can see all of the resources, or all of the services within the resource folder there, which is lovely. And that was all with one click and a couple of types on the keyboard to get this deployed. So not very complicated at all. So do go ahead and deploy that yourself. If you've already got an existing resource group full of services and you want to make it easy for other people to deploy, you can actually export that as an ARM template as well, so that you can have that same template with the same kind of click here button to deploy a full backend. So why don't we go ahead and have a look at the backend. We'll start with the portal and just run through some of the services. So first things first, you'll see that we have here West US, and everything else is in the East US. And what's in the West US? Well, it's cognitive services. Now, the reason that cognitive services is in the West US is because cognitive services is still in preview. So some of the preview APIs don't have availability in every single location yet. Ideally, I would have liked to have had it in the West US just to keep everything within this resource within the same location, but that wasn't possible. There's not a huge latency at all between locations, so you don't really need to worry about this right now. But as it comes out of preview, we will see its locations open up and become more available. The idea of this application is it's a shopping app, so you can buy and sell things. You can upload some images. So we've got the storage for storing images. We've got SQL Server for storing the sale item. So what do we want to sell? If we come into the app service, I want to show you that scaling feature that I mentioned about scaling up or scaling out. So if we scale out, we're going to be creating multiple instances, which isn't very exciting. So let's go ahead and do scale up, which is creating a better instance, a faster instance, more RAM, more cores, and other features as well. So you can see right now I'm on basic, which isn't particularly expensive, especially considering I get my MSDN credits. I get, I think, $150 a month to consume within Azure, and you can see I've got a lot of services running, and each of these have a lot in turn. So I'm spending £20 a month. I could go all the way up to £545 a month if I want a really, really beefy machine. Alternatively, I could go down to free and just use shared infrastructure. So it's up to you to decide which instance you want, but do keep in mind that there is a free instance. You don't need to give Microsoft money if you don't want to in order to play around with Azure. So that's a portal. This is where you would come in and do some management of your application once you've deployed it. But let's actually have a look at the code. Here we have Visual Studio 2015, and it has a project or solution already loaded. And I want to start from, again, the bottom up. So we'll start from the models, so the data objects. And you'll see here we're inheriting from entity data. And I mentioned before with App Service helpers that we have our objects that we register with the tables. Well, these can, within App Service helpers, you're going to need to inherit from entity data as well. Now, in this case, entity data is actually coming as part of this Microsoft Azure Mobile Server namespace, which is cool, but we don't want to have this dependency within App Service helpers. So what we do is we fake this. We make sure that it's got the properties it needs, so that you can just share the class, and the implementation for this is hidden depending on the dependency that you have. So we can basically share this same class from the front end to the back end, so from our client apps to the back end, which is lovely. It's very, very simple. All we have is a string for the name, string for description, decimal for price, and then a string for the URL, which will point to our Azure Storage blob URL, which is pretty nice. If we come into controllers, and I must say, if you've ever built an ASP.NET website, you're already an expert in all of this. So here we have our sale item controller. This is being created for us. This is just scaffolding code. You can get this to create it for you by right-clicking controllers, coming to add, and then hitting controller. You specify a model, and it will create these CRUD operations for you. Again, the important thing here is that we've got the table controller, just like with App Service helpers where we register our tables. Here we're saying that this is a table controller of the type of sale item. Again, this is the object that we're sharing on the client side as well. So again, maximum code reuse. Even though we're going from client to backend, we want to share as much code as we can. Now we have the CRUD operations for things like get all sale items. So that's just going to return an iQueryable of sale item that we can iterate over. We can look up by IDs. We can patch them. We can post them, so we can save. We can delete. Table controllers are pretty uninteresting, to be honest, but you're going to need them. Most of the code is going to be written for you. The only thing I do to most table controllers is come in and add telemetry data in order to get an idea for how well my app is performing with application insights. If we have a look at the by controller, this is a little bit more exciting in the fact that we have an API controller. So an API controller allows us to just have a REST endpoint. I mean, the the table controllers are also a REST endpoint, but in this case we can kind of return whatever we want. In this case we're actually just returning a true or a false, but what's quite nice is that we have this custom route, so we have the URL becomes something.com/API/buy, and then you pass in sale item, and boom, we execute this. Now looking at this, you can see what it is. This is push notifications. If we bring that up to the same line, you'll see here that we have an Apple payload, a GCM payload, a UWP payload. So we have iOS, Android, and UWP, but each payload is different. And it's just because each notification system requires slightly different payloads in order to work. So you can see here on Windows, we're going to be going for toasts. Toasts don't work in Apple notification world. So this payload wouldn't work on iOS. So we need to make sure that we're sending the right payload to the right platform. What else have we got in the back end? We have a small notification service just to deal with Notification Hub in order to get them out. Not a huge amount more in the back end, to be honest. There is a little bit of razor views going on here. What else have we got? Some images. Just not a huge amount. The back end is very, very simple, and I think that's a common thing that you're going to find throughout any Azure development you've done, especially if you've ever built an ASP.NET website. If you've built an ASP.NET website, then everything within the Azure backends is going to make perfect sense to you, and you're going to be a pro at all of this. So that is the back end, a very, very quick and simple overview of the back end. So why don't we take a moment to have a look at the client app. So the client app is the app for iPhone, Android, and UWP. Naturally, because it's traditional, it has 3 different projects, all sharing the same project. So let's just go ahead and launch Visual Studio and take a look at what we're dealing with here. So here we have already loaded for us the iOS storyboard. Now, storyboards are a proprietary format for Apple's UI. It's kind of like a canvas to drop your views onto. Now, within iOS, views have view controllers, and that's going to be the code behind for your views within reason. Kind of nested, so a view as parent is a view controller, and a view controller's parents would probably be a UI navigation controller, and then you work all the way up to the window. So you can see here we have the view controller for, let's have a look, let's zoom in. This bad boy is adding items. We can go ahead and buy items, and it's using auto layout, which is why it's on a square. We can come up to the top and we can simulate running on different devices. So we can simulate running on an iPhone 5, and we need to give the storyboard designer just a little moment to think about that. It's normally a little bit quicker than this, but it's been a while since I opened this, as I was doing the demos earlier, so it's probably shut down some processes in the background. Whilst we're waiting for that, let's take a look at this view controller here. Let's have a look at the code behind for that. So first things first, if we start with the usings, you're going to see that we've got standard iOS usings here. So we've got core animations, we've got core graphics and foundation. We've also got UIKit down here at the bottom, UIKit being pretty much unique to iOS. Foundation, core graphics and core animation, well, the code that you write for that would be shareable with OS 10, UIKit only being unique to iOS. Then we have some namespaces for our particular app, so we've got some extensions just for iOS. We have our models, which is what we're sharing on the back end with our data objects. And then we have services for things like dealing with our back end. And we also have media plugins, and the plugins are really cool. So let me just show you very quickly. So we'll pop into the NuGet package manager, and we'll have a look at the installed packages. So you can see ARC support. So this is for dialogues. So to pop up and say, hey, we're loading some data, or there was an error. But I want to come down and find, here we go, look at this. This is also a very lovely package. Just I'm digressing a little bit off Azure, but this is very, very useful. It can asynchronously download images from the web, and then it will cache them for you automatically. So that's worth having, and it's basically a drop-in replacement for UI image view. It just gives you some extensions. Very, very nice. a must-have if you're doing traditional iOS development. But here we have a plugin, and there are plenty of plugins available. You'll see here that if you go over to jamesmontemagno/media plugin, you can find out more information about this plugin and also other plugins in general. There are a whole host of plugins available. In fact, I think they're now hosted on the Xamarin plugin repository. But yeah, there's just so many different plugins available. This one in particular allows for images, so you can take cameras, you can take videos, and then you can also pick the media once you've taken them as well. So that's pretty nice. It also does things like cropping, which is pretty useful, and it works with every single OS that Xamarin supports. Just from one consistent API, so it's well worth checking out plugins, especially for things like connectivity or location. You shouldn't really need a different API for each platform you're running on, and if you don't use these plugins, then you're going to have to use a different API. So we've got our NuGet packages. Also, let's just drop back into the NuGet packages, and we'll briefly talk about the Azure side of things. So right now we have this, I need to update it, but we can, that's a big change. I know that there's been an awful lot that's happened, so I'm not going to update that just yet, otherwise I'm going to break this demo. I'll get back to refactoring that a little later and then push a new branch for you guys to play with. But you can see here that we've got Microsoft Azure.mobile.client.SQLite store. Very easy to remember and just rolls off the tongue. This will only work on particular platform, so this particular package here won't install and work if you're building WPF apps or Xamarin Forms app. Sorry, not Xamarin Forms. What I meant to say was Xamarin Mac applications. This will work with Xamarin Forms, but with Xamarin Mac applications, this particular package won't work. And it's this SQLite store bit at the end, there's this little bit here that allows it to work offline. So this is the bit where it stores a SQLite version of your remote database on device. Now, this has a dependency on this, which is the Microsoft.Azure.mobile client. If we just were to add this Microsoft.Azure.mobile client, all we would be able to do is call the REST APIs, and we would have an online-only app. It's through the process of adding the SQLite store that we get offline only. Now, App Service Helpers, which I mentioned right at the beginning, which makes all of this infinitely easier, relies on this. It has a dependency on this client.SQLite store, so you need to make sure that you've got that included in your project. We also have cognitive services, and with cognitive services, the NuGet packages are actually mostly referred to as Project Oxford. This is because Project Oxford was the code name for the Microsoft research project that dealt with some of these machine learning projects. So the NuGet packages haven't been updated to reflect the fact that the branding for the product has changed. We also have things like the Windows Azure Storage package, which should be pretty easy to everyone to understand, that this means that you can use Azure Storage. And also, if we pop over to the right-hand side, you're going to see that it already supports .NET Standard. So these guys have been good, and they've made sure that they've got support for .NET Standard, which is what we want to see. Lastly, another little library that's very useful, and this works for Android as well, and Windows Phone, I think, is also supported. Let's just have a look. Project URL. But Splat is amazing. Most of Paul Bett's libraries use Splat, but you can see, so we've got, what have we got? WPF, Windows Forms, wow. Windows 8.1, Windows Phone, 8.1 Universal, and .NET Standard. This also works with Xamarin, of course, so you can get it for iOS, Android. And I think it might even work on the Mac. But this allows you to do things like cross-platform colors, which is very, very nice. So you can just have your colors defined once and then use that throughout your application, and then just call toNative, and it'll give you the native version of that color. So again, well worth checking out that little library. So that's packages for iOS. Let's come back to the storyboard. Has it rendered? Oh, hey, we've now got it for iPhone 5. Let's go back to generic and see if that's a little bit quicker to render that for us. There we go. Always faster the second time round. So we have our lovely UI designer here for iOS. Why don't we run the app? Now we could go ahead and launch it with the debugger, but we don't really need to. So we'll just launch it straight in the iOS simulator that I've already got pre-opened. So you can see it's a pretty attractive little app. We can rate the application through cognitive services. So what we do is we take a photo of you, and depending on if you're smiling or frowning, we give your rating based on that. So if it's a smile, it's going to be 5-star. If it's a frown, it's 0-star. Now in this particular sample you may see a camera up here, but that is just to take a screenshot. It's not to use any cameras because the simulator for iOS doesn't support cameras. So if I click that, it's just not going to work. I'm going to click cancel because we don't need to take a photo. Here we can see bike for sale, very nice. It's 5-speed, love it, $45. It's not a bad price. May have to get that, or we can get a purple bookcase. That's a little bit steep if you ask me. It looks just like a standard IKEA bookcase to me. But we can also come in and we can sell an item. Now, we have two options here, Twitter and Facebook. I have already authenticated in the past with Facebook, so hopefully it should just take me straight through. There we go. So it's actually remembered that we've authenticated with my account before, so I didn't have to type in my username and password. And I'll show you how we do the code for that, because it's actually very, very simple. In terms of adding a photo, we can just tap on the camera, and we are going to sell a monkey. How much, well, what do we want to sell? Sorry, not how much yet. I'm already getting too excited about the profits we could make on this. What do I want to sell? I want to sell, I actually really want the keyboard to come up. Let's see. It's always one of those things. Toggle keyboard, Control K. So I was doing it correctly, just my keyboard control button is a bit sticky. What do we want to sell? Xamarin Monkey. I've got some limited edition ones in the office as well. What is the condition? Like new. I'm not going to say new, but like new. Similar, but not quite. And we'll say this is going to be, oh, it's got to be at least $10. Because they're amazing. Cool. So we can return and then back up. Cool. So that's going to have created my new item, which is very lovely. So you can see the process for that. But I want to talk about that sign in, and we'll pull this up on Android after we've done the sign in, and then look at some of the other code. So let's drop into this shared project, because in iOS we've already had a look at this kind of add sales view controller, and you can see the packages that we've got. There's really not a huge amount that's happening within this view controller that's related to Azure. The whole point of this architecture in putting things in this shared code is to move anything that we can share out of the platform project. So you'll see here, you know, we've got a method, but we're passing in a UI view. Now a UI view comes from UIKit, so this is unique to iOS. So we can't share this with Android or Windows Phone, and that's what we want. We want our code in our view models, in our view controllers and our platform-specific code to only be platform-specific. We don't want to have kind of a pick and mix between POCOs, so plain CLR objects, and stuff that's unique to iOS, Android, or UWP that's scattered in. Now what you can see is that we have things like the add photo button calls this add photo button tapped event. If we peek definition, it's going to take us down the class a little while. You'll see that we use this cross media current.pickphoto async. This comes from the Xamarin plugin. So again, this same API will work across all of the platforms. And then we go off and we get a UI image from the photo file. So again, this is using UI image, so this can't be cross-platform because UI image is unique to iOS. So let's actually have a look at the code that we can share across platforms, because that's really fun. We'll start with the models. So if we come into sale item, you will see that this is remarkably familiar. So it almost looks the same as the sale item that was in our Azure backend. The difference being that this time we're not inheriting from entity data, and also we have some new properties. So we have this date time offset with created at, and we have a string of ID. Now these two properties automatically get added if you're using App Service helpers, because you can just go ahead and go entity data, and we'll resolve to the I spelled that wrong. But we'll resolve to the entity data that's within App Service Helpers, which has the properties that you need already for the ID and the created at and the updated at and all the other goodness that Azure needs to keep track for offline sync. So we have our model. Let's go into our services, because this is where the fun happens. We'll come over to Sale Item Data Service. Now, Sale Item Data Service is how we interact with Azure. Now, you're going to see this if we come all the way up to the usings. You're going to see these three usings. Now, these are what we want. This is going to be for storage, in terms of storing our photos. This is using SQLite, and this is just that standard calling the REST API. So if we got rid of this using and the NuGet package that came with it, we wouldn't have offline sync. If we got rid of this, we just wouldn't have Azure and nothing would work, which would be less than ideal. So if we come down, you're also going to see that we have iMobile service sync table of type sale item. So again, just like with the tables in the backend, we're using generics, or at least this class is using generics in order to specify the model. Sync table is pretty important. Sync table comes through having this SQLite store package. If we get rid of sync, this becomes an online only table. Now we've got some errors. Now most of the errors are going to be related to the fact that these are getting sync tables as well, and this is now just a normal table. So this is an online only table. Every time you call this to say, hey, I want to go and get this item, it's going to call off to your remote service, it's going to fetch that item and return it. So you're going to have to do a round trip. Now, by changing this back to a sync item, boom, we've now got offline sync working. That's really the only modification you would need to take on online only Azure app and make it offline. So that's pretty nice. Because we are offline, we have to actually set where our database's name and where we want to store it. In this case, we're just providing the name. And then the constructor, which is need to find where this is being used. Here we go. Delete. Here we go. In the constructor of the mobile service SQLite store, we pass in the path. Now, if it's just the name of the database, then it knows where it's going to be storing that. Alternatively, we can actually specify the exact location that we want to store this. Now, because we're going to be running on different platforms, we just want to store with a generic name and let the mobile service NuGet package decide whereabouts on the device it should store it, because obviously for iOS, Android and Windows Phone with UWP, the location of these files will vary. So we just specify a name and it will do the rest for us. We do need to specify an IP address, or an API address I should say, not an IP address. If you specify an IP address here, it will work until you try and put it through the App Store, and then Apple will reject it. So this really needs to be a URL, and if I hover you can just about see where I'm testing my mobile app, and it's a very catchy and memorable URL that's being shown there. In this case, you can see that if we're in debug, we're going to delete, but as I mentioned, we don't actually have a fully fledged path here, so it's not going to know where to delete, so that isn't going to work. But we could update that to actually go and find the database and delete it for us, so that we've always got a fresh start when we're in debug, which is always quite nice to have. So anyway, we have our get sync table, and we've got this sale item. So we now have the table available to us within the scope of this class, and that means that we can do some CRUD operations on it. Now, for default, we're going to want to be able to do things like get the sale item, so get a list of all of them, and you'll see we get an IEnumerable of sale item, and we're not animals, so we use async and we use await. So you can see we go off and we sync the items. That's really, really important, and you're going to want to sync the items before you do any kind of CRUD operations in general. The sync sale items method is probably one of the most important within this class. What it's doing is it's pushing our changes up to both Azure SQL and storage. So it makes sure that everything that's on our device is synced up to the cloud, and then it will go off and ask for all the latest information from the cloud. And this, if Android, else iOS, else if UWP, this is that nastiness that leaks in with using shared code. In a portable class library, we would probably use dependency injection to deal with this syncing. In fact, you really, really don't need these if-else for this particular chunk of code, because if you look, they're all doing they are all doing exactly the same thing, so it's pointless. I'm not quite sure why we added that. I'm sure there was a good reason at the time. Finally, we have this buy sale item async, and it's an asynchronous task, and we pass in the sale item, and then we go off and we buy it. So all we have to do is invoke the API async. So this is not a table. So as I mentioned right at the beginning, we have tables and then we have APIs. And because we passed the custom root, so we had the /API/buy. You can see we've got buy here, defining what our endpoint is going to be. We upload the item, and boom, we're going to get a ball back to say true or false. Is this has it succeeded in buying it or not. If we're on iOS, then we have a particular exception that we're looking for. Else, if we're not on iOS, then we're just going to catch any and every exception and write that to debug. So this is the kind of code that we wrap for you in App Service Helpers. We don't want you writing this because this is boring and it can be flaky, and really it doesn't do a great deal of stuff other than CRUD, which we should be able to roll for you without any modification. So we do. So if you're looking at this and you're not interested in rolling your own, then do go ahead and grab Ash, because it gets rid of all of this for you. Let's also have a look at the Emotion API. So the Emotion API is calling off to Project Oxford, as you can see here. We do need an Emotion API key. The API key is pretty important. You can set these up within the Azure portal for any of the cognitive services you're using. We're using Stream, so we pass in an image stream. Now, it's worth noting that with some of the cognitive services, with some of the services, there is a limit to the image size. So, for example, if you take a photo on a brand new iPhone 7, the pixels, probably way too many of them. So you're going to want to scale that down before you try and upload it. Otherwise, you're going to be uploading like a 20 meg image, which on a 2G connection can be pretty painful. And then you can see here we've got the stream. Boom, we go off with that, and then we pass in a rating, and we get some text back. So that's pretty nice. I want to talk about authentication because this is the worst way of doing it, but by far the easiest. So as I mentioned, one line of code to authenticate with Facebook and Twitter, and also Active Directory. What else was there? Microsoft in there as well. Google's in there as well for social auth. It's just this one line of code if you're doing it wrong, which is that web view auth. So we call this login with provider async, and we pass in our authentication provider. And if we just hit dot, you'll see all the lists we have: Windows, Azure, Active Directory, Twitter, Microsoft account, Google, and Facebook. In this case, we're using Facebook. As I mentioned about that redirect URL, in this case it works fine because I don't have any staging slots. As soon as I wanted to test this properly, I'd have a staging slot and all of this would fall apart very quickly. So it's just one line of code to authenticate with the authentication provider, and then we can go and set our user to authenticated. As I mentioned before about ifdef, this is where ifdefs can come in useful when you need to provide slightly different functionality, but you still want the same method names across all of the platforms. So you can see here, login with provider async, and then we pass in the provider. And then if we're on iOS, we'll go and get the key window. We get our view controller, and then we presented view controller. If it's not equal to null, then we VC presented view controller. Right. You get the idea. We take the top presented view controller, and then we call login on it, so that we know where to show the sign-in web view. On Android, slightly different. We're dealing with activities, as you can see here, and then UWP. UWP code always looks the nicest to me, but you get the idea. It's slightly different implementations for each platform called from the same code. So, talking of other platforms, why don't we take an actual look at the other platforms? How do these apps actually look? So here is UWP, and if you bear with me one tickety-boo, I will plug in my Android device. And whilst we're waiting here, let's do that. Let's see how good I look. There we go. Bit of a mess today. But you can see it's taking a photo, and I can smile. It's going to take a miracle to get me lined up with that, because I've got an XPS 15, so the webcam is in the laptop, which is always nice. Need to take the washing out. Perfect. So that's the UWP app. In fact, let's do a little bit more than that. Let's click on a button at least. Second-hand bike. It's that lovely bike that we saw earlier. We're not going to do that, but we are going to load Visor so that we can share my Android phone. So you can see here the UWP version looks fairly alright. £46. Not too bad for that bike. And we'll launch Android. And whilst we're launching Android, let's search for shopping. So this is Visor. So this is mirroring my physical device. This is my primary device. This is Android. And this is actually going to be calling into a separate instance of the backend. And we're calling out or pulling up some slightly different images. So you can see here I've got a TV for sale. Ooh. Seems okay. Looks like I just need to debug this a little more. We've got TV for sale. We have a cat advent calendar for sale for $250. That's a bargain. And then we have an iPad Pro for sale for $5, and it's new. That's worth buying. So we can click on buy. Actually, no, let's go back and let's add a new item in here as well. So we can do that Facebook, and now I'm not authenticated with this app just yet. Oh, no, I have. I take that back because it's already done it. Why don't we go back and have a look at Twitter then? So we'll sell an item. Oh, it's already authenticated me. That's a pain. Well, the Twitter view just loads up Twitter. Let's go ahead and add an item within here. Pictures. Who knows what any of that stuff was. This is a screenshot from Planet Coaster, which is an amazing game. We'll call it Theme Park. Who wants to buy a theme park? And we'll add that item. Boom. It doesn't even have a price. It's free. No validation. Perfect. So you get the idea. We've got pull to refresh, as you'd expect. We have the Android version, we have the UWP version, and we have iOS. If we take a look at the Android code, again, you're going to find most of the code lives within the activities that's unique to Android. Everything that isn't unique to Android is going to be in a service within this shared project, and we're just going to call into this shared code. If we drop into the main activity, for example, you'll just see it's vanilla Android code calling into a couple of shared bits of code which uses plugins like the user dialogues. If we come into UWP, you're going to see a lot of XAML. If you come into user controls and pages, we'll come into the main page.xaml, and this will render beautifully in the IDE, just like Android and iOS. iOS does. So it's all lovely. All of this code is available, I should say, on GitHub for you guys to download. It's MIT, so you're able to do whatever you want with it. It should be pretty easy to customize this and add features as you want. Here we go. We have the UWP version of the app loaded, so you can see the XAML down here. So it's pretty simple little demo, but it does do quite a lot. You've got offline storage, you can take photos, you can use some emotion APIs, and it's got a full ASP.NET backend, so that's pretty neat. So what do you want to do if you want to learn more? Well, as I say, this is all available online for you to download. So you can go ahead to go to GitHub and you can grab a copy of this. This sample is a B2C sample. It's basically a little marketplace, as you can see, to decide to sell or buy things. As I say, services that it uses, cognitive services with the Emotion API. We have Azure Storage. We have off and online sync. Doesn't really make sense with the on, but you get the idea. It's got offline sync. Push notifications, which is awesome. Authentication using Twitter and Facebook, which is great. And what's available is a complete sample app with documentation written by our incredible documentation team. And then we have individual quick starts to get you started with this as quickly as humanly possible. As I say, you can download this from GitHub, which is github.com/Microsoft/Xamarin Azure_shopping demo app. And as I mentioned right at the beginning with deployment, there is a deploy to Azure button. Click that and you'll get to those lovely deployment screens so that you don't have to deal with any of the configuration yourself. To learn more about Azure and Xamarin, you can go to azure.com/Xamarin. We have Channel 9 with the Xamarin Show, which is hosted by James Montemagno. So if you want to learn more about Xamarin in general, this is a great place to come and have a look at weekly episodes on all things Xamarin. If you want to learn in a more structured environment, we have Xamarin University with some of the best .NET trainers in the world, teaching you everything you need to know to be an expert at mobile. They cover things like Azure. I think there was just a guest lecture a few weeks ago, or last week or something, by Liam from Azure Search. So you can learn some really, really great technologies that relate to mobile that might not be, 100% mobile. So it's really, really great resource. Slightly more informal is my YouTube page. You can search for me, Mike James, on YouTube. You'll probably find it. I talk about all things Xamarin. It's much more informal and it's much more kind of as and when I feel in the mood to sit down and record a video. So yeah, these are pretty neat if you just want to see what I'm working on and what I'm getting up to, and a few tips and tricks from someone that's been doing this for 4.5 years or so. Blimey, it's been a long time. So you can find me online at mikecodes.net. I'm on Twitter, I'm on GitHub, I'm on everything. I broadcast myself most places. If you search for mikecodes.net, you will most likely find me. You can email me, mike@xamarin.com. I'm always happy to help out in emails. For the most part, if it is a support question, I will try and put you in touch with the right people. But yeah, do feel free to drop me an email. So that's it for the webinar, but we're going to open up the floor to questions, so please do go ahead and type your questions in the answer box, and myself and the team will try our absolute best to get round to all of you. There may be the odd question where we have to come back to you for it. Apologies if this is the case. Hopefully we'll be as quick as possible. So thank you very much. I very much appreciate you taking the time out of your day to watch this webinar.